Hi everyone, this is Karthik. Welcome again to the fourth episode of the Eyestem webinar series. It's really exciting to have you again with us. As always, if you have any feedback for us, you can leave us, just drop us an email at info@inclusivestem.org. So today, I'm really excited about this show. Like many of you, I always kind of thought that astronomy was something that was largely inaccessible to the blind. So today, we're going to question that. There's some really exciting work going on, and it's my pleasure and an honor to welcome the iData team. So awarded a $2.5 million NSF and Research Development Grant in the United States, iData, which stands for Innovators Developing Accessible Tools for Astronomy, it merges schools and organizations in an unprecedented 3-year collaborative effort to develop an astronomy image processing software accessible to the blind and visually impaired. iData engages both blind and visually impaired and sighted high school students and their teachers at a national level. In collaboration with U Chicago and other university undergraduates, teams in educational research and consulting, and a plethora of other innovative minds, the project seeks to break barriers by abandoning traditional education and design techniques to create innumerable possibilities for all, regardless of vision. The ability to study, discover, and marvel at all astronomy has to teach is made available with the accessibilization done by the iData project. So we have 3 members joining us today from their team. We have Kate Meredith, who is the Education Director at Zurich's Observatory and Education Lead for iData. We have Katja Gosman, third-year astrophysics and physics major at the University of Chicago. And we have Chris Matthews, who is third-year journalism major at the University of Wisconsin at Whitewater. So it's a pleasure again to have you guys with us. Thank you so much for joining us. And over to you, Kate.
Thank you, Karthik. So it's really exciting to be here with you all this morning, and that was a great introduction. It's always very difficult for us to figure out how to describe the iData project, so thank you for that introduction. I'm here, as Karthik said, here in my office at Yerkes Observatory in Wisconsin. So we're in the north central region of the United States, about a 2-hour train ride north of Chicago. And we are a 120-some-year-old institution that was built as an observatory for the University of Chicago. And so we are currently in transition, as the University of Chicago has announced that they choose to cease operations here at the observatory, and we are seeking new partners to continue our work here. We have been enjoying working with making astronomy accessible to traditionally underrepresented populations in astronomy. So we do a lot of work with the blind and visually impaired and the deaf and hard of hearing students, girls in the sciences and technology, and we're looking forward to continuing that in the future. So we're here in my office, and I'm going to share with you the iData project, where it came from, and where we hope to be at the end of the project in a year and 4 months, and what we're hoping possibly to continue doing in the future. And it's just really exciting to me when I met Sanel at the Astronomical Society meeting in last January, and to hear about what you are all doing. So this is my attempt to explain a very complicated project. So to start with, I am going to screen share, and I will describe the websites that we're using as part of this project, and then I will open it up for questions from all of you, for Katja and Chris, and they'll hopefully feel bold enough to explain to you their role on the project and fill in some of the gaps that I might have missed. And so we're starting with a website called Skynet Junior Scholars. So about 7 years ago, we began a project here. It was based here at Yerkes Observatory to provide after-school students working after school with access to lessons that would help them learn how to use a robotic telescope network called Skynet. Now, Skynet is a worldwide network of telescopes that are used primarily to follow up on these rare events called gamma ray bursts. So gamma ray bursts are rather mysterious, colossally large bursts of gamma rays that we observe. It's very difficult to pinpoint the exact location in the sky of where a gamma ray burst comes from, and everyone will be happy to know that they're invisible to the human eye, but we do manage to detect them. After you get the gamma ray burst, you get an afterglow image, afterglow of a visible light, and so it's very important to have a lot of worldwide telescopes point toward where they think that a gamma ray burst may have come from to pinpoint the location. It's very time sensitive. You only have maybe an hour to get this done. So Skynet was developed for that purpose, and these gamma ray bursts happen maybe once a month. So there's a lot of downtime for a lot of telescopes. So they made them available for educational use and for other astronomers to use. So the Skynet website was designed for astronomers to access and put in image requests into a queue for these telescopes. And what my predecessor, Vivian Hetty, imagined doing, because she had been working with blind and low vision students for quite some time, is that we would develop these lessons and make them accessible to everyone. Well, this had some challenges, because if we're going to make a website, it had to be web safe for younger students, so that they would so if they wanted to have conversations with each other, that they would be separated from people who, you know, we may not want to have conversations with students. So this is complicated. So those of you in the computing science area can empathize with the fact that we had quite a hurdle to get over to find in a login system that would work for both the Skynet website and a web portal that was going to be accessed by a number of different user groups. So that over a 5-year period, we developed the site that's now up called Skynet Junior Scholars. So there's a landing page for this website that explains a little bit overview of the project. We've got a picture of the Yerkes 24-inch dome and some information about the site. That is all the farther that you can get into this website if you haven't been granted a login. If you have been, then you have a menu item that's an app, and then you can get into a site, and there's a lot of tools available to you from that point. During that Skynet Junior Scholars Grant, we developed this website, and it has lessons on it. It has a gallery where students can upload images. We have an online notebook, ways and a forum for students to collaborate and talk to each other, to teachers, to science mentors that are available to ask questions from. So what we ultimately want to do is have students be able to ask their own questions about the universe, request their own images from the Skynet website, and then analyze them on online software and talk to each other about their findings. And I'll just go through a couple of points of this Skynet website. What I clicked on first is you land on a gallery, and you'll see images that were recently taken. You see, right now, you see a rather odd dumbbell nebula. It looks a little overexposed to me. And you'll see that, and 2 images of Saturn taken from different telescopes. Those change each day as new images are taken. There is a link to Explorations modules, and when we scroll down on this page, you have access to the basics, how to become a Skynet Junior Scholar, which teaches you how to access the Skynet website and how to manipulate images. There's other projects that you can get involved with, one of which is asteroid research. So we have a wonderful scientist named Tyler Linder, who has been working here with us at Yerkes Observatory for many years on making our rather old telescopes do modern research. And asteroid follow-ups are an area that we can actually make an impact on. So there are other things on the Skynet website. You can access student projects, galleries of images, and then there's resources for teachers and an online notebook for students. What we tried to do during the Skynet Junior Scholars Grant was make all of this accessible to students who with blindness or low vision. And we did a good job to a point. And what we were frustrated with and found out by the end of the grant was that with a lot of help from sighted individuals, students were able to work in the website. But when they got to the point where they had their images returned, what we were saying to them was, oh, you just wait here. I'm going to make your image. I'm going to clean up your image, and then I'm going to make a tactile graphic of it, and I'm going to give it to you. And that's not accessible. So we want students to have equal access to the same quality and quantity of information as their sighted peers. And it doesn't help to participate in the actual science if you only get to make an image request and then you have this completely inaccessible data processing software. So then we decided we needed to write another grant. And that's where the idea of innovators developing accessible tools came from. We knew that if we wanted to have a web available data processing software for astronomical data, that it needed to be developed by students who were going to use them. So I'm going to go over just a moment. I did not show you the Skynet website. So the Skynet Junior Scholars web portal, as we call it, accesses and connects with the Skynet Robotic Telescope Network. And it has its own separate website. So using a single login, students who are part of Skynet Junior Scholars are able to access both tools. And professional astronomers are also able to access the Skynet Robotic Telescope Network. And what we've done on this website is you can go to a link called My Observatory, and you can take request radio or optical observations. Now, my menus, for those of you who can see it, have a lot more links to them than the students would see, because I am all powerful on Skynet. So we've got optical observing, and when we go to that link, then students are able to see images that they have acquired. They're able to go to a separate link and add observations to this. So this is the page where student observations requests are returned, and through a separate link, you're able to make image requests. The image request system is inaccessible. It has a lot of visual tools for targeting objects in the sky, and you have to choose your worldwide telescope network that you want to capture images on. And so one of the tools that we thought would be helpful in allowing students to access the power of the Skynet website is to use command lines. So when we were exploring how to write Skynet, the iData project, we decided that one of the most powerful tools was computer programming, and that we also connected with one of our partners at the University of Nevada at Las Vegas, and they had been working for many years on an accessible programming language called Quorum. And Quorum is research-based, and they make commands with this language that are more user-friendly. So in order to get your program to speak to you, you just use a say command. So things are more language-based that are easier for students to use. So through the Skynet Junior Scholars website, we are accessing Quorum programming language to code in commands that replace this inaccessible page. So students learn how to use computer code to access this page. Now, the overall idea here is that we're providing students with tools that they learn, and they know that these are tools that they can use to build what is the ultimate goal of the project, which is data processing software that is not visually based. So we know that when a scientist points a telescope at objects in the sky, that we returned data. It's just numbers on a spreadsheet, basically. And we go to great lengths to make that information visual because it's easy for visual people to do. But it's not inherently visual, and 90% of the information that comes to us from space is invisible to the human eye anyway, so there's absolutely no reason why this data should not be fully accessible to blind and low vision students. So even though the iData projects, it was actually funded to see what happens, we're doing educational research to see what happens when we engage blind and low vision students with their fully sighted peers and their teachers in a user-centered design of data processing software, that the ultimate goal is usable data processing software that students of all abilities can use. So I'm going to just go back to the Skynet Junior Scholars website, because most of what I'm just going to explain to you is just a bit of the process here. So we started 3 years ago, or actually 3 years ago, writing the grant. So last summer we met with, we had undergraduate interns here at Yerkes Observatory, and we started the process of learning what it was really going to take to make this accessible. So we have undergraduates here with blindness and low vision, and they worked with other undergraduates who are fully sighted and the iData staff to start designing accessible lessons. This is one of the things we needed to do, was basically grow our own astronomers who can then, in the words of Wanda Diaz-Merced, learn to complain bitterly about the process and improve it so that we can ask our own questions and answer them using online processing software. So you don't have to download anything to your computer. You just have to have a stable internet connection, which we know is sometimes a challenge. So that is the process of iData, and what I'm going to do now is I'd like to hand it over to Chris and then Katya to talk about what their experiences have been with iData. They've been both extremely dedicated to making the curriculum that we're developing to work with the high school students who will come here again this summer and work. They'll be here in a couple of weeks, and we're going to go through a design process with them, with design professionals, to input ideas into the Afterglow software. So they've done very little work with this software right now. They've been learning astronomy. We've been working with asteroid light curves, and we're going to learn we're going to design how that data needs to be presented in a way that students without assistance from a fully sighted person can get into the data and work with it. So I know there's so much. It's taken us 2 years to understand this project. So this is my best attempt to explain what we're doing in under 15 minutes. So I'm going to hand this over to Chris, and I'm going to let him tell his story, and Katya, and then we'll see what kind of questions you all have. And Chris, you want to go first?
Sure.
You're right there.
Perfect. Well, good morning, and thank you so much for having us here. And as Kate said, my name is Chris Matthews, and I am a journalism major at the University of Wisconsin-Whitewater. And iData for me represents something that I think at times has been a frustrating process, and also a process that I think we're all learning from. One of the biggest problems that I've personally had with iData, being someone with a visual impairment, is the fact that most of the concepts that we're trying to teach, a lot of the astronomy, we've had to backpedal quite a bit because there just aren't the resources and the accessible resources available to make astronomy accessible. And so last summer, as we were developing a series of hands-on education lessons, it became apparent to me that there was a lot that I didn't know and a lot that I had to learn. And that has only kind of grown in the last year with this project. And so a term that we've coined here at the observatory is accessibilizing. And that can range from looking at a website, and I joke that my job here is to look at everything everyone else has designed and tell them why it's broken. But that can also mean going into a closet full of arts and craft supplies and coming out with a lesson a few days later that is accessible to both blind and sighted students. And for me personally, one of the most rewarding experiences was developing a lesson on CCD cameras, where we used string and duct tape and poster boards like foam board and mat pins to represent a CCD interface and the different colors. And to develop that was one thing, and to take that into a classroom and actually watch students understand the concept, and actually some of the sighted students even put on blindfolds and still were able to get a grasp of the activity. And so my role in the project, I am terrified of words like coding and some of the astronomy. Being a journalist is a little bit different, but it's skills that I think are going to be really useful because I don't understand some of these things. I think I'm a good test subject in that when it comes to students who are going to be doing things with Afterglow, with iData, after we're done with the development process, they need to understand things. In order for that to happen, I need to understand things. And so this project has really been a learning experience for me, and I really enjoy doing a lot of the accessibilizing and a lot of talking to people and kind of finding out what it is that we need to change and how we need to change it, because all of this is uncharted territory. And so that's kind of my role within the project, is finding out what needs looking at, whether it be the website, looking at things with a screen reader, or working to develop activities for understanding concepts in coding and in basic astronomy. So that's kind of what I do on the project. And I've been here at Yerkes for about 10 years on and off on various, I started with, Kate mentioned, Skynet Junior Scholars. I was working with Vivian Hetty on a lot of the tactile images. And so now I enjoy presenting at star parties and talking to people about the physical accessibility we have here at Yerkes, and anything that I can do to accessibilize things is why I'm here. Turn it over to Katya, who is also here, and she can talk about her role on the project.
Hello, everyone. I'm Katya, as you already probably know. Thank you so much for having us once again. And so I am a astrophysics and physics major at UChicago, and I am fully sighted. So this project, basically last year we came in and we had to learn a whole new way of thinking, because we were tasked to design different hands-on lessons for all the students in the project, as Chris was saying. And it was a lot different than designing regular lessons, because we had to take into account that we needed to make these accessible for everyone. And so we needed to figure out how to represent concepts that have usually been represented visually to us and make them accessible so that you didn't need vision to understand them. So for example, one of the things we did was, in order for students to understand the electromagnetic spectrum, usually that's presented with a poster and it has like a range, and you would go from radio to gamma, and it would be very visual. And instead what we did is we made these cardboard puzzle pieces, and on each of them we tactily made a spectrum with string and pipe cleaners and other objects. And so that way, if you are visually impaired, you can run your hand over the spectrum and feel how the wavelength changes, how the frequency changes, etc. And so it was a very cool way of trying to think about different concepts in a new light. And we also had a lot of fun. A lot of us learned Braille last year just to learn it, and so that we could also accessibilize things if we wanted to. Umbrella, okay. What we are also doing is us and also some of the interns that are here this summer, we started off in our first week of the internship by making these umbrellas, and they would basically represent the dome of the sky. And because usually if you go like into a planetarium show and stuff, they would just show you and point out different stars, or if you're outside and looking up, you can't really touch those. So in this case, we had an umbrella, and we had students tasked with trying to represent certain astronomical concepts, such as right ascension and declination, the ecliptic, the meridian, constellations. tactily. And so they work diligently in groups with these big dome-looking umbrellas that would cover your entire head. And they decided to put things like pipe cleaners and string in order to mark the grids of the right ascension and declination. They put beads in order to mark the constellations, more string for like meridians. And then people like Chris and another intern named Alex, who's also here with iData, who's also visually impaired, got to test that and give us feedback. And so we're working on refining those umbrellas more and more throughout the summer. So hopefully by the end, we'll have some nice umbrellas that we can show off at star parties, which we've actually already been doing. We have a lot of stations during star parties that show off our tactile activities and images that we've made. So like one of them, last year, I took basically it's like a globe, but instead of the map on it, it has constellations on it. So the celestial sphere. And I decided to stick on gemstones on the constellations, on the stars, one by one, and then connect them with hot glue. And so that in that case, you could also take your hand and you could feel where all the constellations are in relation to one another. You could rotate the globe and you could see what the sky looked like at a certain point of time. Yeah.
So thanks, Katya and Chris. So that gives you some of the ideas about what this project is doing. iData has the team of educators here at Yerkes Observatory, but we also have the programming team from the University of North Carolina at Chapel Hill. They're the coders on the Skynet website and for the Afterglow Access software, which I'm not going to show you today because we're keeping that hidden from the students and the public until we get a chance to get design input onto that software. And we have the Quorum programming team at Nevada. We have user-centered design experts on this who are scientifically gathering user information so that we can tell the programmers how to change things to make it more accessible. And we have a large team of researchers on the project looking at what happens and how we can make this process better. Because the ultimate dream is that we will continue to do this. We want to work with deaf and hard of hearing students more in depth than we have in the past. And I look forward to designing things that are specific for autistic students, and we want to do more with language development in general. So there's a lot of aspects to this project and potential for the future. I see that this project will not end the development process on Afterglow. We only have a year left. Designing takes time, and teaching people and designing lessons that allow you to learn how to use the tools is a long process. So we will continue in the future, and I look forward to Yerkes Observatory making the transition to a new entity. And my personal dream is if you are a other abilitied astronomer, deaf and hard of hearing, blind or visually impaired, autistic, I want Yerkes to be the place that you come to kick off your career. So we'll open it up to questions if that works, and we're just really thrilled to be here today.
Thank you guys. That was really awesome. For anyone who wants to ask a question, you can either unmute yourself or type your question in the chat window.
I would like to go on.
Yeah, go for it.
Yeah, so this is me, Abhisar, here again. I would like to explore on the possibility, like I would like to know your insights. Like how do you guys plan on explaining the dimensions, like keeping in mind the string theory, sorry. Like how do you like plan to explain a dimension to a visually impaired person?
Well, luckily, we don't have to launch off into quantum physics or string theory yet. We're still working on concept. We're working for this project. We need to, some of the concepts that we've needed to develop lessons for are the electromagnetic spectrum. So all the different types of waves. We have worked on probably the most challenging one is explaining how a CCD camera works. Because when we look at the process of actually coding the commands that we normally just visually push a button for, we want students to understand the steps in that. So that's part of the process of teaching all the computational thinking that goes into designing a piece of code that then we send off to the software. So the CCD camera has been one of our most challenging ones so far. Katya and Chris, what are your thoughts on explanations here for this?
I mean,
Go ahead.
I mean, I know that personally, I don't know exactly anything about string theory. It is a very high-level topic that you don't learn in your undergraduate career, and it's a very specialized field of physics that you usually go into grad school for and study many years to understand it, and it's very mathematical. So I don't understand anything about string theory besides what I've read from popular science books, and my best guess is to dimensions. I mean, I don't exactly know what a dimension is in the way that probably string theorists think about it, but the way I think about it is that you start off with the first dimension, which is a point, and then the second dimension is like a line, and then if you want the third dimension, you get a cube. And then going on from there to higher dimensions, it becomes a lot harder because you can't visualize or understand what a hypercube is or anything above that.
Actually, I was quite excited about how do we go for space and time, explaining those dimensions.
So I would challenge you to you get a grant together and we'll come visit you and we'll share information.
So I think that one of the biggest things in terms of explaining a lot of complex astronomical topics to anyone with a visual impairment is the fact that to go forward, we really have to go pretty far backward. Because here, a lot of times in school, when astronomy comes up, they're like, yeah, there's some planets and they do an orbity thing and let's do some Earth science. And that's one of the things in iData that I think we've realized collectively is that we can get to the point where we can do string theory, maybe. But I think that the first thing is that, on almost every lesson that I've had a hand in helping with, there are concepts that we have to peel back almost like layers and understand. And so I think we can get there, but to go forward, I think we really have to go back and think about how we're redesigning the ability to explain these things in a non-visual way.
Okay, makes sense. Thank you.
Thank you.
Anybody else, guys? Go for the questions.
This is Supriya. So sorry. I just wanted to know, are there any standards to explain what an image is showing? For example, what you had on the screen was the Saturn. And so what would you do to describe that to a visually impaired student? Are there any guidelines?
So that is actually an excellent question. And guidelines, I would love to come out with a kind of standard way of doing it as we move through the project. We have done work with tactile graphics here for many years, and we know that we need to teach students how to tactily interpret the data that they're touching, just like students have to learn what they're looking at if they're sighted. But we don't have a standard way of doing that. One of the tools that we're providing kind of a crude start to is a sonification tool in the Afterglow Access software. And we're going to get the students' input onto what works for them, and then look at a process for interpreting those. So my hope would be that after we work with students on a sonification tool and we develop it, that a visually impaired student could sonify an image and interpret the difference between a galaxy, a globular cluster, an individual star field, and also interpret what is a out of focus image or a image with maybe the telescope isn't tracking, because that's our first step, is we have to know what a bad image is and if our data is good. So we do not have a standard for that right now, but there's people working on that as well. We have an astronomer visiting from the UK this summer, just arrived a couple of days ago. Dr. Nick Bond is working he's a galaxy expert, and he is also visually impaired and has been working with 3D modeling of galaxy data and how to help students interpret tactile models of galaxies. So I think that that's part of that, but we would love to, if there's anybody else doing that level of research that says, here's a standardized way of teaching this, that would be absolutely super. Anybody else here have something to add? Chris?
So it's really interesting. That's a really good question, Sophia. And I think one of the problems that we have at the minute that is on its way to being solved is about 10 years ago when we started these things at Yerkes, one of the requirements for doing any kind of tactilization was a machine that we colloquially call the toaster. And essentially it's a laminator-like device that raises up ink on special paper, but that requires any facility, be that a school or an observatory or museum, to have this piece of technology. And one of the things that's on its way to helping with that is things like sonification. So if we can use some kind of a method that's also connected to the internet and the resources that are already available, that I think would be the better way to do it, so that if students open something like Afterglow, there is already a tool there. And like Kate said, Dr. Bond's research in 3D printing, that's really becoming a more readily available technology. But the other possibility to me is that there's probably something that we're not thinking of that might end up helping. And so if you guys have ideas for that, that's something that, it really helps sometimes to just step outside and get a fresh perspective. So I think that's a really interesting point that should be probably further explored.
Put it on our list.
Yeah, in fact, it's very interesting because there are many students here who are intrigued by astronomy, but from what we find in this from the teachers is the lack of ways to explain. At the same time, tools like what you have, sonification, the things that you're working on are pretty much not available here in India. And so we would like to probably, be in touch with you to ensure that we learn with you as you were doing the research.
That would be super. We, just like, what we were describing, we received support from our local Lions Club International. They're very interested in issues related to blindness and low vision, and they supported Nick coming here, Dr. Bond coming to the observatory for the summer. We try to fly in people who can help us and then take what we know and just disseminate information. I'm always up for a good trip. So is Katya and Chris, by the way. So, I think it's the more we get groups together and learn from each other and learn the challenges that each of us face, we have some of the same challenges that you face in our rural areas in the United States. Very high poverty rates in the rural areas, very poor internet access, and students need that same kind of help. So we are well aware of that. And when we get to the end of the iData project, it would be wonderful if we could say, okay, these are the lessons that we know work. And now, what's the question? How do we package these so that they can go anywhere? And that is another question. So let's keep in touch.
Sure. Thank you so much.
I guess we have a question on the chat.
Yeah, we
Kate,
have a question from Bhavya on the chat.
Yeah.
Okay, I'm pulling up the chat. Okay. Since this is a web-based tool, will the accessible explanation be text descriptions only, tonal representation, or tactile 3D models and graphics too? Mm-hmm. Yes, all of that. So Chris, did you want to?
Sure. Yeah, so we are actually using a little bit of a lot of things. I'm actually working on writing a text-based kind of screen reader guide to using the Skynet Junior Scholars, and eventually probably Afterglow Access. So text and the way that we're writing these modules is also being worked so that when you come in with a screen reader, one of the initial problems I'm personally having is I don't understand coding in the first place. And then when you put in, and just one of the commands, for instance, said output telescope. But what it doesn't tell you is that there are quotes around the word telescope. And so little things like that need to be adjusted for the fact that we use screen readers. So screen readers and text are definitely one outlet. The 3D printing and tactile modeling is something that we're still working with. And of course, sonification, for me personally, is my favorite because I like audio things. They help me understand things in more clarity. So, and again, there might be another method here that we're just not even on the radar with quite yet. But yes, we are using pretty much anything and everything we can get our hands, ears, eyes, fingers, anything on to help us to explain things. Because again, like I said before, one of the problems I think that honestly the world has in terms of blind low vision astronomy is there are no explanations for things. And so even a project like this, for what it's doing is fantastic, but to get students up to a point where they understand these things is a challenge. And so I think that working with everyone we can to develop resources to get everyone on the same page and understanding astronomy is really the key to allowing for blind and low vision astronomers.
And we did make the decision early on the project that we would develop our tools to be, we would test them almost exclusively with NVDA as our screen reader of choice, because it is free and it is open source. So we've had to make some limiting choices on how we're going to make things work, and so we keep looking at what other technologies are available, and with outside support, we're trying to get our hands on prototypes of different technologies that might be helpful. And I think in the next 10 years we're going to have many more live tech, the haptic outputs from computers. I think there's just a lot of potential out there.
So, Kate, this is Sona. Oh,
yes.
Bhavya has a follow-up question. You can add my question to that too. One thing is, I had a question. We have this many Eyestem members here interested in astronomy, and you showed your accessible website with the login access. Do you think you can get some of them involved if they are interested in testing out prototype or anything where they can also interact with your students and get real experience learning?
I think that would be really great. The challenge that we have right now is finishing the project on time and developing the tools that we are obligated to get some closure on, and having enough staff time to support other users. So as our undergraduate mentors have ambition time, and they have this tendency to stay up really late, I think that is an avenue that we can look at engaging these students on. In fact, Chris has a friend. Why don't you tell him about your outreach efforts?
Yeah. So I'm actually a Middle Eastern Studies minor in college, and so I started taking Arabic. And through networking and on Facebook and things like that, I ended up making a friend from Palestine who is going to be helping us with testing things and the like. And there's an 8-hour time difference, so I somewhat frequently stay up until odd hours. And yeah, it's fun. But I think that's something that I think we all collectively take for granted, even though there isn't much here, that we need to be able to make this a collaborative effort. So I would really love to meet some of you guys and work with you guys. That would be awesome.
We have a question about, you've So we had a question about partnering with Space Camp and NASA, and Chris has been to Space Camp twice.
Yes.
And so maybe you can think about how can you imagine us partnering some ways with Space Camp and how?
Yeah, absolutely. So Space Camp, for those who don't know, is an absolutely fantastic facility in Huntsville, Alabama, here in the United States. It's kind of down south, so it's a lot warmer. And it was a lot of fun. Like Kate said, I went twice, and that taught me a lot about accessibility in astronomy because they had Braille labels on every button and switch in a mock-up orbiter, which real astronauts use to train for NASA. And what they did with accessibility and how seamless the process was absolutely incredible. And I think that, you know, post iData in some way, shape, or form in terms of the world accessible astronomy scene, Space Camp can, and in my opinion, should be an essential part of that process because what they've already done on their own with their facility is absolutely extraordinary.
So I had two questions. One of them has to do with sonification. So are you guys like, so one thing that so I've used things like math tracks, for example, from NASA just to understand like, you know, basic kind of images and graphs and stuff like that. So but I kind of struggle sometimes with understanding more complicated stuff. So again, are you doing anything special or sort of like what attributes you're using? Is there anything specific to like make things you know, more like I guess easier to use or easier to understand, especially given that it often takes like a while to get used to understanding like different components in the sound. So is there anything specific going on there? And the second question is, have you guys explored like more like interactive surfaces where you can essentially, you know, sort of mock how something would look like, and then if you touch like different portions of that surface, you can get information, real-time information about like what that particular component does or what that means. So like kind of getting hands-on with an image.
Now that is cool. The second question, no, we have not explored that, and part of that is just that we're so focused on getting the online software to work and get that developed, but looking at creatively about how we could, I should just talk with you offline a little bit more about that. The first question about use of sonification. So what we've done, and this was a lot of debates and a lot of meetings about how far do you go in the design process, how many tools do you give a group beforehand. You don't want to influence them too far, but you want to give them enough to work with and push back on. So what we've done, and we have a very awesome programmer named Josh Hayslip, and he developed the initial sonification tool. So he used the best research that we have about what, you know, how we can hear, what the distinctions are, how much detail the ear can hear, how do we present that in with headsets, and how do we use spatial orientation plus tonal value, pitch, volume, those different aspects. And we've put that into an initial tool, which you can adjust many of the parameters on. So you can adjust the number of tones that scan through an image. So we've developed, there are some standards already about in what order do you scan an image set or data set, what order do you sonify in. We have people on our advisory board who have done, we have Ed Summers from the SAS organization who have done the graphics accelerator, so they are sonifying graphs for blind and low vision screen reader users primarily. So we are trying to follow some standards plus provide the students with some tools to explore. But we also know I'm actually getting to the point where I've used the sample images enough so that I'm getting a sense of what does a galaxy sound like and what does diffuse light, how is that interpreted on these algorithms. So we can mess with these, change these algorithms in a lot of different ways. So as we go through the process, we will probably need to do research individually on how that's interpreted. And we know that we have to teach sighted people how to interpret a visual image, And the same we expect to have to do with sonification as well. So I think that, you know, a year from now, we love to have maybe we can have another one of these sessions a year from now and specifically look at the sonification tools and what we've learned and how we can partner with other groups. For example, there's Jamie Ferguson is doing his PhD dissertation in Glasgow, Scotland. We're just looking at how can we auditorily interpret noise in data. So there's the data that you want plus the noise, there's in focus, out of focus. So how, and can we, he's actually testing how accurate people are in interpreting different types of auditory output. So I think that that's important. Getting the users to input onto the design process is important, and then actually testing how accurate people can be using those tools, because we want to bring everyone to the same level of ability to interpret data.
That sounds awesome. That's something that I kind of struggle with, like on and off as well, because especially when you're working with large data sets, sometimes what fellow data scientists can do is, you know, just scrap it out and like see anomalies, but I actually have to like write my own scripts to programmatically figure out, oh, you know, this is kind of different and these are the parameters that I need to look at. So like, you know, any tools to kind of just get access to the same sort of information that other sighted people have access to in terms of the data is something that is super useful.
Excellent. Chris, did you have something to add?
Yeah, okay, so, and I'm not sure if there are, I guess, limitations to this, but I want to ask, because there have been a lot of really good ideas, and iData really has kind of, I don't want to say constraints, but there are only certain things that we can accomplish in the time the project has. And so what I'm thinking, and I only do this sometimes, so watch out, but I think it would be cool to start a Facebook page of accessible astronomy and add a lot of you guys, because the ideas and the things that you guys are coming up with, I think are fantastic ideas for things that we should all work on, you know, in conjunction with or following iData. And I think we need to have a network of people so that we can bounce ideas off each other and do this kind of thing in a less formal but still definitely recordable and usable environment.
That'll be awesome. Yeah.
I don't know if everyone here has some, I don't know how to even facilitate that process, to be honest.
Yeah, I mean, everyone here is on Facebook, so it should be pretty straightforward to just add everyone to a group and get that discussion started.
That would be fantastic. Yeah, I can definitely create a group. I just think it would be really cool, and I can send this out to our project, and we kind of have a network, so we can definitely kind of snowball it.
Yeah, I had a quick follow-up question. So we're talking about, again, sonification and 3D models and tactile graphics. One of the things that I've struggled with is, again, and especially in a country like India, is again, how do you get this data there? Like especially models and like, you know, a lot of the kind of stuff. And also, again, given the time that it takes to get used to 3D audio. So coming back to Bhavya's question about sound, when you guys are generating, for example, alt text for some of the images to provide just a basic understanding of the layout of the image, is that something that, I mean, and then given the advances in computer vision as well, are there any plans, maybe not as part of the project, but later on, to leverage some of that research and say, hey, we know some of the objects in this image. Can we somehow determine the relationships between different objects and at least provide a basic understanding to the user who might not otherwise have access to some of the other cooler technologies that are otherwise available in the States?
Thanks. That is yet another great question. So because my predecessor, Vivian Henny, was so dedicated to making everything accessible, and the iData project is pushing everything that we do here at the observatory toward the accessible area. Another project that we're involved with is that I do the website work and the curriculum development for the Sloan Digital Sky Survey, which is a whole nother giant data set that is inaccessible. And the website, though, the educational materials we are attempting to make accessible. So this alt text question, which seemed to be very simple, has not been simple. So Chris was actually testing some alt text that we developed for the Voyages website, and it started a complete discussion about how could you provide just a short description, and how do you decide what actually really needs to be interpreted just to get through the lesson, and then provide another resource that's a little deeper that looks at the image and allows that same exploration. So I can just say, well, it's a spiral galaxy and blah, blah, blah. But what if you wanted to have somebody who's sighted looks at this and they get a lot of information? So how do you provide a short version and then a back end version? Wouldn't it be fun to just be able to then sonification becomes like this thing that is just done with images if it's sitting in the background and it can be accessed through a screen reader. I don't know that's helpful, but yes, I agree. You should be on the team. Katya, Chris, Chris is creating a group on Facebook as we speak.
Oh, awesome.
Assuming the name is not taken, I have not tried yet, but I'm going to try to call it Worldwide Accessible Astronomers. So if you look in the next 15-20 minutes or so, I will have that as a public group up on Facebook.
Awesome.
And that way we can start doing all of the networking things and actually sharing ideas and talking to each other and making things accessible.
Awesome.
Hey, Patrick, I have a question.
Yeah. We have a question from Bhavya as well. Sure.
Okay.
Guys, if you go for it first, we can get.
Okay. Hey, hi guys. So Akashdeep here. I have a question that, like, when you were mentioning about the electromagnetic waves spectrum, so I got just query that the concepts like group velocity and the phase velocity, for which we generally use the animations. Have you tried to explain them, or what approach exactly you have tried?
Are you talking about like group velocity and phase velocity of waves?
Phase velocity and the group velocity concepts.
Yeah. So I think I actually learned about what that is, I think, in school. But that is very deep into the physics side of this, and it's a concept that currently we're not focused on teaching the students of eye data. Because it's something it's not specialized, but it's something you would learn in an undergraduate physics class, as I did, or in an intermediate electromagnetic waves and optics class. But I would say if you could, just as we represented the electromagnetic spectrum and the differences in wavelength and frequency with something like string or pipe or something tactile like
One sec, Karthik, can you please mute yourself? We really can't hear her.
Oh.
Okay, go for it.
Cool. Yeah, just as we represented the basic electromagnetic spectrum tactilely, it could be possible to represent group and phase velocity also tactilely. I know if you have a wave packet where you would have a bigger wave with a longer wavelength, and then inside of it you would have the wave with a much shorter wavelength. That's how I've seen it represented in some of my classes. But I think it is also something like a lot of other physics concepts that most students, unless they're going into physics, don't really get into until they're in college, if they even are getting into that.
So what we'll do is build our way up, and when Katya's done with her PhD, she's going to come back here and fix all those other problems for us, and we'll keep growing our cadre of accessible scientists. I do want to loop back to I had a note in the chat that we didn't actually talk about the question of getting 3D tactile graphics into developing countries, and I think that would be a really great question to look at, and because we actually have the same question here, just how do we get them from our project into rural areas of the United States? And so I think that that's a question I will bring this week to Dr. Bond, because he's helping us learn how to make high quality 3D graphics. And we will look at, what could be a distribution mode. So that would be about getting a connection in country, sharing files, seeing what printers are available, testing, making sure that we've tested these file formats on different printer types, seeing how understanding how different groups use them, what are the possible distribution networks, and packaging them. I know for myself, there is an amazingly great tactile backpack about spatial relations in the solar system and constellations that was developed in Argentina. I cannot get a hold of one of those to save my life, and I can't figure out how to make one myself. They've done great work. So this idea of sharing and distributing and producing in-country great resources that are developed around the world is an issue, because why reinvent the wheel? Why reinvent something that someone else has done, and we just figure out how to distribute it? Because I think there are challenges everywhere. So I'm actually going to start pursuing that this week, because that's a question that's relevant to this project and important to everybody.
And along with that idea, I think so far, because we're just starting to create these networks where people all over the world can come and talk to each other about these issues like these with accessible astronomy, like as Chris is creating his Facebook group. A lot of these things, like for example, files for 3D printing can be distributed a lot easier, because you can just send them to a Facebook group probably, and then people all over the world can have access to them. I guess the major roadblock in this would be getting materials and getting the actual prints out to people all over.
Right, and that brings up this really deep issue about education and science. So when we invited Nick Bond here to help us with learning about his work, is that he, as a scientist, doesn't get recognition or pay for doing really great outreach work. And so finding funding and support for creative minds who care about outreaching to underrepresented communities and populations is really serious. And even doing just education work in science is highly undervalued. So finding ways to fund these. So if we all stick together, I think part of it is just continually raising awareness and doing things, and then saying, and by the way, we cannot do it without financial support. And I think that finances are one of our biggest hurdles. We're not lacking for creative minds and great ideas. And so we will just keep forging ahead.
Well, something great that has happened this week that tries to make this even easier, I guess, is the U.S. Senate actually approved ratification of the Marrakesh Treaty. So that is actually great news. We can actually now legally share a lot of these resources as well, even books and whatnot. So really looking forward to what we can do with that. And something that the Diagram Center at Benetech in Palo Alto is trying to do is they have this whole repository of 3D printed files that they created for a bunch of math and science books. I suspect that something similar could be done for astronomy as well, and there could be like a repo of sorts that people could have access to. And because I think 3D printing is not necessarily a challenge, especially if you think about even like places like urban India. We have a bunch of those in our leading institutions, so we could definitely get hands on that. I think it's primarily just those files and just the expertise in creating those in the first place.
Yeah, I know that sharing, as a National Science Foundation grant, I've had to fundraise separately for anything I try and do internationally. And the expertise is distributed globally. There are smart people everywhere working on issues of equity and accessibility in astronomy and STEM, and opening that up more so that we can collaborate more, so that I can use funds that we raise as part of a National Science Foundation grant to bring in and enrich projects and distribute that information. So because science is such a global endeavor, so when I look at some of the other projects I'm on, Sloan Digital Sky Survey is an international project. And so to be able to the supports within country that support that international collaboration they're really important.
Guys, Abhisar here. I just wanted to talk to you guys about how when we are talking about the sonification thing, how about you guys, like what do you guys think about collaborating with the laser interferometry gravitational wave observatory? Like recently when they discovered the gravitational wave when the two black holes collided in September 2015. So they depicted that through the sound waves. They depicted that through that. So how about you guys collaborating with them for more sonification works?
I mean, I think that would be a really cool idea. I remember when the announcement came out, I was in senior year of high school, and then when I got to college, we actually have one of the scientists that worked on LIGO, Daniel Holes. He is a professor at my university, and he gave a little talk to the undergraduates and any people, and he played us the sound, and we could hear the chirp of the two galaxies colliding, which was really cool because that was actually the first time that I had ever thought or heard of the idea that you could sonify data like that. So I think collaboration with them in any case would be really awesome.
Yeah, definitely. And also like in few like billion years also we know that the Andromeda is going to collide with our Milky Way, right? So if we could like think of doing something like predetermining how it would occur or what would be the outcomes, could that be a way using the sonification thing?
Yeah, that gets into the whole area of computer modeling, and I think that's part of the reason, on the project iData, that we're trying to stay focused on those, developing those early skills of thinking about a phenomena, and then also knowing how a computer understands those processes and how we code to do those things. So we get from actual physical models to computer models. Computer modeling is definitely not part of what iData is doing. But so if we stay focused on the piece that we're doing, and we learn how to do that really well, which is teach students about basic astronomy and physics concepts that lead to the ability to interpret data, leads to the modeling. And so even though we've got endless number of good ideas, great resources out there to tap, I think that we are seriously challenged in just making sure that we do our basics in a really accessible way so that we can continue to grow astronomers.
And because for people to want to get into all of the really cool stuff like gravitational waves, and like everything that's a lot more complicated than that, you first have to explain, as Kate said, the basics to them. And a lot of them don't get that in school, and they get very frustrated even at a basic level because they don't understand those concepts. And everything in physics and astronomy builds off of one another. And so what we're trying to do is get them a baseline, a foundation that they can have for like continuing in astronomy and pursue that if they wish. And then getting the really complicated things accessibilized is also like a different project that could be another really huge effort.
So we look at even basic challenges here. So we have a popular magazine that's actually published very close to the observatory here called Astronomy Magazine. And even I have a very minor visual problem, and I cannot read that magazine after 5 o'clock in the evening because the graphics are so flashy and complicated that it inhibits my ability to actually access the text. And so we have been working with them for months to get them connected with the National Federation of the Blind to do audio versions of releases of that magazine, just so that astronomy becomes a popularized thing for available, because it's just interesting on an amateur hobby level for so many sighted people. It should be that way. That access should be available to a blind and low vision people as well. And if we do that, those are some of the really basic things that ground level interest. So that leads to conversations, leads to interest, leads to I want to go to space camp, leads to I think about this issue of accessibility even on that level, and I hope to someday get to gravitational waves.
Yeah, and I mean that whole thing about becoming interested, that is how I got into astronomy. Was when I was little, there were resources that I could use. I would read books about it. I would watch movies and TV shows about space. Read the magazines and all that, and basically getting all those big ideas in my head and getting me interested is what got me to this point, actually, going to college and studying it scientifically.
I think that's one of the interesting things about iData, because actually prior to going into journalism, I wanted to go to space. I actually wanted to do that. So I went to space camp twice because they put Braille on the shuttle. So obviously it was possible. And the thing with iData is, even with a project like this, people are interested in what it is. And I think that is what we need to do anything. We've got to start with something. And I think we're going to have to build in two different directions. We're going to have to build backwards so that, like Katya said, and I know Dr. Bond, the way that he really started to be interested in space was watching a documentary about the Voyager missions and realizing how far away that was. Well, how do you explain that to someone who has no vision at all?
Right.
And so just this whole cycle is kind of, I think, all indicative of the fact that we need to go back to go forward.
Does anyone who's not asked any questions have any questions? We can go on and on.
Yeah, we could.
Anyone who's not asked a question who would like to ask anything?
We have got a question on the chat.
Yeah, I want to answer the question about the population that we're serving. So sorry for not addressing that. So we are targeting students in high school. So we have 8th graders, so that's age 14 through 17 as part of our student group, their teachers, and then the undergraduate mentors who are, most of whom are now going into their second year of university study. And does iData have a course for computational thinking for students? Okay, we have spent all months of really interesting meetings, even debating what portion, how are we defining computational thinking, and how are we going to test for that? Because that's actually one of the focuses of the grant research is what impacts are we making on students' computational thinking skills as being part of the grant. So in those, on the website, the portal, where those modules are, the students are introduced to the concept of computational thinking, but we're also trying to be very targeted on building those computational thinking skills. So in its simplest form, what we're focused on is students understanding how to break a problem down into steps that a computer can execute. So this idea of how does a computer think, how do we break a problem down into executable steps. So we start with the image request, so they have to code the steps to make the telescope point, so that you have to know where is it in the sky, what telescope do you have to send a command to, do you have a count time on that telescope, and then also what filter do you want to use. So there's that one task alone, requesting data from a telescope, requires you to learn 5 different astronomical concepts and do a bit of coding. So yes, that's what we're doing. We're directly addressing computational thinking as part of these modules, and we're getting in deeper and we're learning how to not do it. Chris has scolded me numerous times. I I think I have a meeting with him yet this weekend to be corrected further on how we're doing it. But yeah, this is a challenge, and we're trying to work on that.
And a lot of things with computational thinking is that obviously it involves things like obviously it involves things like coding, which is also not exactly particularly accessible either, as we know. Rocker is complaining to us bitterly about how much he doesn't like it. But that is one of the things that in order to teach them that, we also need to teach things like basic concepts of coding, such as the variable. And so with that, we're trying to get over that hurdle by also making hands-on activities with boxes, which we are just starting to develop about, how exactly does or any programming language work in a basic way. We also have videos that I produce with another girl who goes and be like the star on the show. And we basically go and explain, what are these commands, how to use them, how to type them in a auditory and visual format.
Something that we are invested in actually is to start this process. Go for it.
Yeah, so that's what I was saying. It's really interesting because I think here in India, for most of the special schools, this is a topic, this subject is just out of the curriculum. So it would do great for us to know how you do this and then learn from you and then probably try to introduce, because we don't have it in schools here.
So I'm hoping that by the time we get to the American Astronomical Society meeting in January of this year, that we will start having some preliminary results that we can share from the project in a more scientific and cohesive way.
I think in terms of a process, the other thing that's really interesting is honestly, there isn't a process. And so what we're doing is we're trying to develop something. But what I can say is one of the best ways to start doing something right now in schools there is honestly just talking and exchanging ideas, going into, any kind of resources you have, physical resources, and just using them in whatever ways that you can to develop anything that you can with it, if that makes sense.
Okay.
So just taking and starting somewhere is really the best way until we can give you more concrete results.
Sure. Thank you.
Also, guys, talking about the black holes, when a sighted person sees, he doesn't actually notices it, but the person has to notice the quasars, right? So without the tactile diagram, when we talk about image processing and the afterglow, how does how far the afterglow can take a approach in explaining a visually impaired person about a black hole, which almost nobody can see, only the quasars can explain it.
I think that is also something that we can't really image black holes, at least with the telescopes that we have. We don't usually do that. We focus more on basically objects such as clusters or galaxies or nebulas or planets. So black holes is not exactly in our region yet of what we're.
Yeah, we chose to start this project with addressing something that a medium-sized telescope that students can have access to in the future, teaching them to do asteroid follow-up imaging, and we're really focused on capturing a light curve so we can assess the rotational period of an asteroid. This is, so it's not only a great test case, but it also, when the students who are part of the project now are finished, if they choose to continue this research on their own, it's available and they're able to do it. So they come out with a skill that isn't just theoretical, but they can do. And so the challenge is pairing, for right now, for working with students, younger students, is what is a project, a scientifically valid project that they can do with the resources that are available, and Skynet is our best resource. So, the the Giant Magellan Telescope's never going to be on Skynet. And so there's some avenues of research that just won't be open right now. But the idea would be that, it's a completely blind scientist who wanted to work with Giant Magellan data, maybe we'll have an impact on that in the future.
Yeah, and I mean, if you're talking about high school students, they can't very much readily do research with a black hole just because it involves things like general relativity, which people don't usually learn until maybe upper undergraduate years, but mostly graduate school. I certainly have not learned any general relativity yet in my career. It's like an upper level course, my graduate course at my school. But it is definitely something that, again, as we look forward, and after we've gotten the basics down, we can start, getting all these higher level physics concepts accessibilized as well.
Definitely. I mean, that was lovely, guys. Thanks.
Also, the Facebook group is it exists. It's not pretty at the moment, but I finally got it to connect. It is called Worldwide Accessible Astronomy. So if you guys would like to join the group, hop in, and hopefully we will see you guys on the Facebook side of things.